Okay, so in this video, we're going to continue our study of recursion and look at a little harder examples. So the previous examples were quite simple. They were just the introductory examples. And now we're going to look at a harder example. So first, let's recall what recursion is. So what exactly is recursion? Well, the idea of recursion is breaking down a problem. And let's break that down into simpler and simpler problems. And once we break those down, we can break those down into simpler problems and so on and so forth until we find a solution for our simple problems and then combine them all together to solve a bigger problem. And so an example that we've already seen in the last video is what is the value of n factorial, right? What is n factorial equal to? And so we've seen the definition of factorial before. We know that n factorial is n times n minus 1 times n minus 2 times all the way to 1. And so the question is, how do we do this recursively? One of the definitions that we can have, or one of the tricks that we could use, is the idea that n factorial is equal to n times n minus 1 factorial. And with that, essentially what you can see is that we are trying to solve the bigger problem, which is what is the factorial of n. And we can break that down into n times a smaller problem, which is the factorial of n minus 1. And so the question is, how do we solve factorial of n minus 1? Well, the factorial of n minus 1 is n minus 1 times the factorial of n minus 1 minus 1. And this will continue on and on and on until we reach finally a base case where n is equal to 1. And we know the trivial answer is going to be, 1, right? N factorial, where n is equal to 1 is equal to 1. So that's our trivial little simple example that we've seen with recursion. And now you might be asking, okay, we've seen recursion, we've seen this idea of breaking down problems into simpler version of problems. But at this stage, you might be asking, come on, the examples that we've been showing can be easily done in an iterative fashion. So what's the big deal here? So we can, do factorial iteratively, we can do the Fibonacci sequence iteratively, but you know, what's the big deal here, right? And I'm going to show you an example today where, it's a problem that is beautifully captured by thinking recursively, and it's pretty hard to do iteratively. And through this example, I'm going to show you the power of recursive thinking. And the example that I'm going to be showing you guys today is something called the Towers of Hanoi. So let's look exactly at what the Towers of Hanoi example is, and let's see how this encapsulates the idea of recursion. So the problem states, given three pegs and n disks such that all the disks start on the leftmost peg, what set of moves should we make to make all the disks end on the rightmost peg? And one of the caveats to this problem is that we can only move one disk at a time, and a larger disk can never cover a smaller disk. And so you can see here, here's a literal picture of what it looks like. And mathematically, we can prove that the optimal move count is 2 to the n minus 1. Now, I'm not going to go into detail why this is the answer, but just note that the optimal move count for any number of disks with 3 pegs is 2 to the n minus 1. Okay, so here's a little picture or a little video that shows you exactly how this will take place when n is equal to 3. In this case, they're actually using the left peg as the starting peg, and we're going to move all the pegs to the middle peg. This example is the same thing as our example where we want to move the left peg to the right peg. Sorry, all the disks from the left peg to the right peg. It's really all the same. Okay, so this looks pretty easy with n is equal to 3. But in the real problem, n is equal to 64. And in that case, how do we know what set of moves that we should make? So then you might be asking yourselves, how do we solve this problem? Well, since this video is about recursion, we're probably going to be using recursion. And so there's a few steps that you're going to need when you're solving a recursive problem. The first problem is going to be, what's our overall problem? What is the overall question and what is it asking us to do? Well, in this case, the overall question is, how do we move all n disks from the leftmost peg to the rightmost peg? Right? How do we move all 3 disks from the left all the way to the right? And once you've solved that, once you've understood what problem you're trying to solve, right, you can ask yourself, what's our smaller problem? What is the smaller, like, intermediate problem that we're trying to solve? Just like in the factorial problem, what is the n minus 1 factorial? And that'll help us solve the bigger problem. And so in this question, it's how do we move the first n minus 1 disks to the middle peg? And finally, what you're going to need to do is ask yourself, what is your base case? What is our base case in this problem? Well, in this problem, if we only have one disk left and that disk is the last disk at the bottom, then let's just move it to the end, right? And so let's look exactly how this works. So here I've set up a little figure where we have n is equal to 4 and we have the 3 pegs set up. And so let's look exactly how we might do this. So once again, we want to move, our overall problem is move the 4 disks from the left to the right peg, right? All the way to the rightmost peg. Our base case is going to be if we only have one disk left, then let's move it to the end. And our subproblem or our smaller problem is how do we move the first n minus 1 disks to the intermediate peg, right? And so let's look at how we might do this. So first, what we're going to do is we're going to move our n minus 1 disks to the middle peg. Once we've done that, what we're going to do is we notice that we have the last peg, or sorry, the leftmost peg with the nth disk at the bottom, right? Then what we're going to do is we're going to move that peg, or sorry, that disk from the leftmost peg to the rightmost peg. Then what we're going to do is we're just going to move the 3 disks from the middle peg to the rightmost peg. And we're done. It's as simple as that. That's the recursive thinking that we're going to try to solve, right? And you might be thinking, that's not exactly how the problem is supposed to be made, right? Well, in this case, we're trying to think of it recursively. And with recursion, you kind of have to take a leap of faith. And so it's that simple. So let's try coding it up together. Okay, so here's the problem on DMOJ that exactly, shows this problem with Towers of Hanoi. And in this problem, we have a given integer n that we take an input as, and then we're going to print this set of moves that we should make in order to solve this problem. Okay, so let's do this. Okay, here I've opened up CP Editor with the input as 4, and here are the expected set of moves that I should have. So first, let's take an input for the integer n, and what I'm going to do is I'm going to call a function, Hanoi, and what it's going to be is it's going to have parameters as intn, which is how many pegs do I want to move. Then I'm going to have a character c, character start, which is going to be what is the node that what is the peg that I'm starting at with these n disks. Then I'm going to have my ending peg. Which peg do I want to end these n? Do I want to finish these n disks off at? And then I also want to have an intermediate node, or peg in this case, where I can use that to solve my problem. So if n is equal to 1, if I have one disk at the bottom, let's just simply move it from our start to our end. And then return. So we'll stop this recursive function, or this recursive call. Then what we're going to do is we're going to say, okay, we have n disks that we want to move from our start to the end. Right? So what we're going to do is we're going to move the first, the top n minus 1 disks from our start to the intermediate peg with the ending peg as my intermediate peg. Right? I want to move all the first n minus 1 disks out of the way so that I can move my last one, my 1 peg, or my 1 disk from the start to the end using the intermediate node or intermediate peg as, as an intermediate step. Then I'm going to move my n minus 1 disks from the intermediate peg to the end, using the starting peg as an intermediate step. Okay. Then what I'm going to do is I'm just going to call the Hanoi function on the n disks with A as my starting one, C as my starting peg, and then B as my intermediate peg. Okay, so let's run it. And as you can see, it works perfectly fine. All right, so let's submit the code. So here we're back onto the page, and let's submit it in Java. And so as you can see, it works perfectly fine. And that's all you need to know for the Towers of Hanoi, which is beautifully captured with the idea of recursion.